Let's give an example of how to diagonalize a matrix. In this case, I'm going to diagonalize, for just an example, the matrix 1, 2, 1, 0. And the very first step is to find eigenvectors and eigenvalues. So I'm going to find eigenvalues first, and then I'm going to find the eigenvectors for that matrix. I have done this in another example, in another video, so I'm going to be a little bit quick about it. Here, what you do is you find the determinant of A minus lambda times the identity. And if you do that, that will be the determinant of the matrix 1 minus lambda, 2, 1 minus lambda, which is minus lambda times 1 minus lambda minus 2. And that is lambda squared minus lambda minus 2, which factors as lambda plus 1 times lambda minus 2. Right. So this tells me that there are two eigenvalues, minus 1 and 2, the two roots of that polynomial. Great. So now I can find eigenvectors for these eigenvalues. So two eigenvectors the eigenvectors, I have two eigenvectors. So I have two eigenvalues. I have this eigenvalue, and to find that eigenvalue, what I find is the null space of the matrix that I get when I apply lambda equals minus 1 here. So it's lambda plus the identity. And when I do that, I did that in some other video, as I said, it turns out this is the span of the vector 1 minus 1. Okay? So just it's a one-dimensional space generated by 1 minus 1. For lambda equals to 2, I can do exactly the same thing. I compute a null space of A minus twice times the identity. And that was also one-dimensional space, is the span of the vector 2, 1. Great. So now I have two eigenvectors. It's a 2 by 2 matrix, and these eigenvectors, because they are associated to distinct eigenvalues, they are linearly independent. That's something the theory shows, and therefore we have a basis of eigenvectors. And I can try to diagonalize my matrix. So I do have a basis of eigenvectors. So I'm going to write a basis of eigenvectors, which is the new basis I'm going to use to change basis to this one to get a diagonal matrix. So my new basis is going to be given by these two vectors. So it is going to be given by the vector 1 minus 1 and the vector 2, 1. And that is my new basis of eigenvectors. This is the eigenvector that corresponds to lambda equals minus 1. This is the eigenvector that corresponds to lambda equals to 2. So my diagonalization, I already know what the diagonalization is going to look like. It's going to look like minus 1, 0, 0, 2. But let's see how that actually happens. So when I do a change of basis matrix, so I'm going to write the change of basis matrix. That is a matrix B that has 4 columns, those vectors that are the eigenvectors. So it's the matrix 1 minus 1, 2, 1. And a change of basis matrix, I can change this is the original matrix with respect to the canonical basis. If I want to change that matrix with respect to this basis, so then the new matrix A with respect to that new basis of eigenvectors will be given by A times B, the change of basis matrix, times B inverse. So it will be given by, well, remember what is a formula for the inverse of a matrix, of a 2 by 2 matrix. I'm going to write it for you right here. Remember that A, B, C, D inverse is 1 over AD minus BC times D minus B minus CA. Okay, so I'm going to use that to compute the inverse matrix. The inverse matrix will be, the determinant of this is 1 plus 2 is 3. So it's a third of, and then just, what is it? It's going to be 1 minus 2, 1, 1. So that is the inverse matrix. So if I write that, so for this one is a third minus 2/3, 1/3, 1/3 times my matrix. My original matrix was 1, 2, 1, 0 times the change of basis matrix. That is 1, 2 minus 1, 1. And that is precisely, if you do it all out, I get minus 1, 0, 0, 2. And this is my final answer. This is my diagonalized matrix. A is that matrix, and I have to tell you what the basis was to be able to diagonalize, and this is the basis of eigenvectors, such that when I change A with respect to that basis, I get a diagonal matrix. Last, I will say that I always get confused, and I always try to figure out, like, is it BA B inverse or B inverse times A times B? And the way to remember this is that this matrix is the matrix that goes from the new basis to all bases, which in this case is the canonical basis, but it goes from new basis to all bases. So this one goes from all bases to new bases. So this matrix is with respect to the new basis. It takes vectors in the new basis and gives you vectors in the new basis when you multiply. So this is correct because this one takes vectors from the new basis, converts to the all bases. This one goes from all bases to all bases, and this one goes from all bases to new bases. So if you multiply by a vector here, you see that you get from new bases to new bases, so this is correct. If I had done B times A times B inverse, it would not match if they are vectors with respect to the canonical basis or this new basis. So this is right, and you can just check that when you multiply all those three matrices, you do get the diagonal matrix. So anyway, this is how you diagonalize a matrix.